boys and girls. Hello. Hello. Let's see if my face is working. My face is working today. Very happy about that. Yesterday was not working because my PC was too busy thinking to other stuff, but I restarted it and now it's working fine. Ha 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 ha. Very, very nice. By the way, someone followed during the intro. Thank you, Judge Slayer. Hello, thank you for the follow and welcome to the stream. We have a strange picture of the day today. Wow, like an army of people going into the sewers area to do something. I don't know what. Remember that these screenshots are the screenshot of the old game. But anyway, as you can see, there was there was a freaking border already. The border here, the split between the two sections is anyway evident. I think, you know, we will have, in Unreal, we will have to export those and make a single model and export it again, because it's a bit silly that, you know, we made it modular because we really wanted to reuse pieces at that time. But I think that now we can probably make it one piece and that's it. And that's it. You cannot believe it's the old game. Yeah, it is. It is. I mean, pretty much all the pictures of the day are like of the old game. The one that are Unreal, you see on the bottom left here, the Unreal symbol. Okay, so I'm putting it on all of them. So like even these ones, you know. So it is, you see, it is Unreal. Yes, this symbol, and it is new. So you can always tell if it's new or old, and not only you, but also me, because sometimes I don't, you know, maybe I don't remember exactly which ones. Even if, I mean, it's kind of possible to easy to recognize, mainly if you look at the shadows, right? We didn't have any stencil shadows at that time, so. Okay, so what are we working on today? Today we want to work on still artificial intelligence. So I'm still going a bit deep into these tribes, because I want tribes to be functional, or at least, let's say, I want to be sure that I personally understand tribes a bit better. Consider that most of the code for tribes has been developed by someone else, by a guy named Magodra, which I've been still in contact with him a few years ago, but he was very busy. And so he never came back, but I really appreciate what he did. He did a lot of work there and really helped a lot the game, and he will be remembered. He will be remembered. Maybe one day, you know, I will come back. There is, you never know. You never know. You know, the hobbies are cyclic. You know, so sometimes you have the hobby, then it goes away. Then he comes back, you know. So maybe the hobby will come back again for them, and some will return. You never know. You never know. You never know. So yes, in many of the sources, you will see his name. I think he signed it with the nick, right? With the nick Magodra. But yes, a lot of that has been done by him. Now, he was not completely finished because again, it was done in the spare time. But then another piece, another significant piece of the artificial intelligence has been done through the Google Summer of Code, when we were chosen by Google as a notable open source project, and so we ran the Google Summer of Code. I don't remember where was it. I think it was 2012 or 2011, probably 2012. I don't know. And And so there we had a few programmers. They were paid by Google, basically. I mean, paid by us, but we were paid by Google. So a young guy just out of university, or mainly during university, just as a kind of a summer of code, and they did some good pieces. I think that, for example, some of the recipe has been done by them, you know. So not exactly external people, because at the end they became, you know, part of the team somehow, but let's say not permanent people. And yeah, for example, this guy, Z. Yeah, 2011 probably, seeing the date. Z did a lot of this part, like all the recipe, and I think the beginning of the tribe probably was done by Magodra, and then there was an extension by this Google Summer of Code guy. But anyway, and then I touched a bit the code myself as well, but not too much, and that is why I don't know this part of the code very well, and this is why I'm trying to learn it, understand it. Okay, so just to summarize, I restarted my PC, so we have all the stuff in the wrong place. So just a second, because as usual, what is here? No, nothing critical. And here, yes, this one maybe. Let me close it. Sorry, I'm back. Don't worry, nothing happened. We were, yeah, I need to reopen all our tribes. Tribes 1, tribes 2, and tribes 3. Let me see if I do open with. No, because it's a single file, it cannot do it. Too hard for Windows to actually open 3 files with an app. So you have to select them one by one. So yeah, these are the 3 things. So I don't want to re-explain tribes. Maybe some of you were not here, but I think it's a bit long to explain it. But basically, tribes for us is a way to have a kind of a hive mind. I mean, a single mind, right? A single mind which is determining the actions of a tribe, so of a group of NPC 1, NPC 2, NPC 3. Now, the important point is that the tribe itself is a brain, so the tribe itself thinks and has its own thinking, and also the NPC are ticking their brain and they have their own thinking, right? So it's important to understand that they are separate entities for the code. So the tribe gives, let's say, the high level inputs, right? And the NPC is executing those high level inputs by translating it into stuff that he knows how to do. So for example, if the tribe says, go and search for food, right? The NPC will go and search for food the way he knows. Or if the tribe says, go and mine, right? The tribes will, the NPC will do it, right? Now we went through that a bit, and at the moment, yeah, we were working on this. At the moment, we had, I didn't have any time since yesterday, so basically we are exactly at the same point where we were when we stopped yesterday night. But basically we arrived to a point where we realized, you know, that part of the code was not working as we were expecting. In particular, the tribe is telling our NPC to do a few things. In particular, it's telling them to reproduce, which is this line. He's telling them to gather resources, which are these 2 lines, and he's telling them to build some buildings. Okay, so to create some buildings and use them for the expansion of the tribe. And which is kind of a, you know, minimal test case to test all the functionalities of tribes, right? So remember that here we are in the test database, so in the test instance of our game, and so we only load the minimal data to be able to create proper cases to test the code, right? So doesn't mean that, so this is not really meaningful, you know, from the evolution of the world, but it's meaningful to test the code that we have. Yes, the big brain has a lot of IQ because it's the sum of all the other brains, I guess. So what we have seen yesterday is that the tribe can reproduce. So the first one is actually properly completed. The second one is also properly completed because the tribe can mine coal. But then the third one is not properly completed because actually the third one requires the NPC to know where there is a gold mine. And unfortunately, when you discover a gold mine, for some reason there is a bug that the NPC is not giving this information back to the tribe, right? But this bug actually allowed us to make another more important reasoning, which is some of the recipe, and recipe meaning one of these lines, some of the recipe may fail, right? May fail. And if it fails, we don't want the tribe to continue to try endlessly to execute that particular recipe without checking the rest. Because let's say that, like the example we did yesterday, the tribe wants to mine for gold, right? Want to mine for gold. This is the gold mine, right? And these are the two tribe members, ID 20 and ID 197, right? Which are two tribe members. So maybe they are instructed to go to search for gold, and they actually go to search for gold, but while they go to the mine, maybe some players is killing them because the player don't want them to reach the gold mine, right? Now, at that point, with the current code, this guy will die, and the tribe will send another guy to the mine. And this guy will die, and the tribe will send someone else, and someone else, and someone else, you know? So it will continue to fail without realizing that it's failing. So from the tribe point of view, the IQ 1000, which in this case would be IQ 10, is not realizing that his tribe members are dying while going to the gold mine, and so they cannot mine gold. So unfortunately, with the current code, what happens is that the tribe will continue to try endlessly to execute this line and in all the sublines, because actually this line expands into many other things, but it will continue to do that without realizing that it cannot achieve it, right? While, for example, it could stop doing that for a certain amount of time, and it could say, okay, I cannot reach gold today, right? So let's start to build something, or let's reproduce, or let's search for coal, and then I will retry maybe in 3 hours from now, and maybe those pesky players will be gone, and so we can finally mine my gold, right? And so the players will see that the tribe is not sending anymore the warriors, and say, okay, the tribe understood that it cannot come here, and so that the players will go happily to sleep. And while the players are sleeping, the tribe is saying, now I can finally mine my gold, right? So that is exactly what should happen. Now, this mechanism, right, of understanding failure is something that doesn't exist in our code, but it's something that we absolutely need to add, or I want to add, because I think it's important, right? And so yesterday, after a long rambling of few hours, we arrived to that point. So we arrived to the point to say we need the concept of failure, right? And we started to implement it, and then it was too late and I had to go. So we are starting from this point. I hope the explanation was clear enough. And so in particular, what we need to do, we need in the recipe tree node, which is basically the tree that is keeping the structure of all the actions that the NPC needs to do from the tribe perspective, okay, not from the NPC brain perspective, from the tribe perspective. We needed 2 new variables, which are the one that we added yesterday. Yeah, if they don't remember the mistakes, they will repeat them. Yes, and well, let's say that in our case, they will repeat them anyway, but we want them to realize that maybe there's not the right time to continue failing, right? We want them to realize that they can do something else, and then they can restart at a later date. So now this task is not an easy task. There are multiple parts to be able to implement this failure recognition, but I don't think it's too complex either, so I think it's very doable. So the first 2 things we need 2 variables. One which is telling us how many times the requirement failed without any progress in the task, right, since the last progress, right? So we need to consider that maybe some task will progress but will not complete, so we still be considered a failure, like a partial success, right? And so in that case we could anyway consider it as good. There's something that move forward. And the second variable is the last known value, meaning which was the value that we had when we last executed successfully the task, or we progressed in the task, right? So these are the 2 things. Now I need to put my brain in this case again in this context to remember exactly what I was thinking. But I think that we need these 2 variables. We need these 2 variables set when we fail, right? When we fail. So going back to our breakpoints, and by the way, I think I should undo what I was doing here, if possible. I cannot because the file was saved and my machine was restarted. Okay, it's not a problem. It's not a problem. We can do this. No, fuck. I didn't mean this. Anyway, I meant this, and we can compare with a base, and we can go exactly in that place, exactly, and yes, and I think I want to get back whatever we had, right? Whatever we had. Maybe I can just improve slightly the comment, but yes, this one should be reverted. Okay. So what this guy is saying is keep the same step for concentrated recipe and pick the next one for distributed recipe. So which is basically this, I plus 1 and I, okay? So this part will remain as it is. I don't have any problem with that. But we need to be sure that when our requirement is failing, because here we are speaking about requirements, right? Now here the point is, this is a loop, right? And it's looping on all the requirements. So if one requirement fails, I want to flag the node I want to flag the node as failed, or do I want to fail, or do I want to flag the requirement as failed? That's a very good question. That's a very good question. Because if we flag the recipe, is easier. So I could say check, 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 right? Check, 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 check. We fail. We fail. Right, so we fail the requirements. So we store, right? And I use those two variables that I just added. One is failure since last progress, and the other one is last value, whatever, last known value, right? Now there is a bit of a special case, which is the first run. So so yeah, I think we can do a bit of a trick and have last known value. I think we can initialize them both as -1, okay? So that we are sure that these ones, I hope there is no copy of, but potentially no. Okay. Visual Studio is always slowest than humans. So we set this one as -1, and we set the last known value is -1 as well, right? When the tree, now I don't know if there is any copy of the node. I hope not, because if the node is getting copied, we need to copy these values as well, right? But I think I don't see a copy functionality, so I think it should probably be fine. Hopefully. Okay. So we initialize them as -1. Now, if they are -1, right, for whatever reason, now they go always together. When we set one, we set the other. So in reality, we can just check one, you know, maybe the one with the shortest name. We can just check one to check both. So if last known value is equal to -1, it means that we failed for the first time. And failing for the first time, I don't think it should be counted as an accumulation of failure, because the first time is normal to fail, because our algorithm works this way, right? My NPC wants to do something, it cannot do it, and so it's executing a strategy executing some action to complete it, right? So the first failure is normal, is expected, right? So I think the first failure, we don't really care, so we don't trigger the right, we don't trigger the failure last the number of failures. So let's say if it's different than -1, right, I'm thinking to the 0 value, but the 0 value will never happen, right? Because it will go from -1 to 1. But anyway, so if it's different than -1, So let's say we ignore the first failure as it's by design, right? Value equal to -1. So this one we ignore it. So on on the next ones, we store, right? We store these values. No, actually, storing the value, we need to store it anyway, boys, because otherwise it will not work, eh? We store the value we reach with this run. Let's say we store the value. This phrase is not correct because we store the value. We store the value at the present time. Yes. Yes. Now, how do I do this? How do we set it? I mean, this one is easy. This one is just a ++ on this guy. So, right? And this one is easy. We just increment the failure count. Okay. Now here, we store the value at the present time. How do I know? How do I store the value? How do I store the value? That's not very easy, or it is easy? Ah. We have a problem though. We have a problem. The problem is that each requirement may fail and each requirement may have a different value. Because there is a for loop, boys, huh? There is a for loop. There is a for loop. So my node, going back to our example, this one can be get 100 gold, get 10 silver, okay? So they can be two separate requirements, right? Which are in the same recipe node, right? And one of them may fail, right? One of them may actually, in our case we are not failing here. In our case we are failing at the mine gold, because this is where our code is. I also need the database. Wait, I don't have the database up. And now I have to try to focus on where we fail, right? Where we fail. So for sure, the first run we fail here and we fail here. So these are both failures, right? 100%. But there is the failure that happens by design. The failure that happens by design is because we don't have 10 silver yet, and so, or 100 gold, and so we fail and we ask the NPC to go and mine gold, right? But then at the next run, well, mine gold will also fail because we said that we don't have this prerequisite, which is a location for gold, right? So this one will actually fail as well. Because mine gold has a prerequisite. I think I'm doing something. I mean, I think I'm not explaining things well here though. Because one thing is the node. And one thing are the prerequisites. So the blue is the node. The pink or whatever, the purple is the prerequisite. Right? So in reality, mining gold in our case is the one that is failing. But because this pre-location for gold is failing. Now, if that pre-location for gold would not fail, if that pre-location for what would not fail, which is here, is this line, right? Is this line. If this line is not failing, yeah, but it's failing on the prerequisite anyway. He's failing on the prerequisite. He's failing on the requirements. He's failing on the requirements. The problem is that he's failing on the requirements, but what we need to stop, we need to stop the recipe. We cannot just stop it. We cannot just ask him to skip this requirement, right? Because this requirement is needed for this to be properly executed, right? But we need I think we need a mini array. We need a mini array. Or we allow only one failing. Well, actually, I think that's kind of the case because this is a 4, but when he fails one requirement, you know, if it's the first requirement, is anyway returning -2 and he's bailing out, right? So this guy is not going to execute all the requirements. He's just going back, right? He's just going back. So and then he's moving to the next requirement. You can make a wild failed recipe greater than successful collation plus 10. Then yeah. Then we will add the logic of, you know, where is the threshold. But here we are before the threshold, because the threshold will be important, but will be important later. So later we will decide, you know, when we want him to stop trying, okay? But that's the second part of our problem. We are still on the first part of the problem, which is to to store the failure and then detect the failure. Okay, so basically we have three pieces. We have three pieces to this problem. We have store the failure, right? Then detect the too many failures, okay? So detect, let's say, the threshold. And then there is the, you know, the take action, do something else. Let's say they do something else. So So our problem is actually divided in three pieces, right? In these three pieces. And our problem is exactly, you know, these three pieces in sequence. So at the moment, I'm working on the first one. At the moment, I'm working on storing the failure. So how do we store the failure in our code so that can be then later retrieved properly? And here the question, and here the variables that I added are on the node and not on the requirement, right? But I don't think at this point that is probably the best idea. I think I need to put it probably on the requirement. Otherwise, so where, sorry, I'm lost a bit of where are the requirements? Where are the requirements kept? Where are the requirements kept? Wait a second, I'm a bit lost on that. I'm a bit lost on that. Is inside recipe. So if I go inside recipe we have the children requirements. Yeah, this one. So we have the children requirements inside the recipe, and yeah, at this point I think that one way, yeah, I think we need to do it inside of this. I think we need to do it inside of that, boys. It's probably the right place. Because it's actually the single requirement that is failing, but then, yes, it's also the recipe that is failing as a result. But we want him to be able to move to the next requirement. We don't want him to move to the next recipe. So if the recipe is distributed, so that's the idea, right? Yeah. I think so I think I need to move those two variables inside requirement somehow, right? Now there is a big question. Are the requirements unique for each tribe, or are the requirements shared between different tribes? Because if that's the case, I'm fucked. Meaning that I think they are shared, boys. What I mean is that if one tribe is executing this thing, and another tribe is executing the same thing, right? Are the requirements unique to each tribe in terms of where they're kept in memory or not? So do I do a new recipe, or do I just take the recipe from the list of all the recipe and I just link it? I think I just link it, boys. I think I just link it. That's a big, if that's the case, but I think it's the case, that's a big issue. Because this means that when we load I mean, is there one tree for everyone? Well, no, the tree for sure is different because each tribe has his own, you know, his own definition. But when I'm inside a tree, is this requirement unique? Yeah, I think it's unique because it may have different values. It may have different values. So I think that probably when we load the tribe, we do a new. Oh, I hope so, because otherwise it will be really a mess. Really a problem. Load member, load memory, load resource. Tribe load. Because I remember that like we said in the wiki, I remember that the NPC manager was loading all the recipe before. So we said NPC client loads from database all the tribes, MySQL tribes. For each tribe, NPC manager load the tribe load information. Blam 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 blam. For each tribe, he calls recipe manager tribe, which parses the requirement and skips them in the recipe class. So I think there is the moment where we do it. So we need to check. Recipe manager at tribe. Right? We need to check this. Recipe manager at tribe. And check when he's loading. Yes, load recipe. Get recipe. But the recipe is added, but recipe get name. There seems to be a static array. We do a new recipe tree node. So actually this one gets instantiated new, but I'm not 100% sure that the recipe that's inside, you see, is passed as is passed as a pointer, right? So yes, I create a new recipe node. So the recipe node is actually new, but the pointer to the recipe is static. Is absolutely static. So this means that this means going back, you know, if I'm mining coal or if I'm mining gold, in both cases, I will go on this recipe, which is miner dig resource, right? And this miner dig resource is shared between the two. And so if we are failing on mining gold, at the moment the code don't have the understanding that that's different from mining the other minerals, right? In terms of failures. So I think we need to yeah, they build a tree of node made of recipe requirement, but the actual recipe are pointers too, right? So the recipe are reused. So I can add my variable on the recipe tree node, and we will be good. So these two are actually unique for my tribe. But if I put them inside these recipe requirements, this one is actually shared with the other tribes. And so my only solution is to do this. So it's basically to have a structure, okay, dedicated to my and now we can also do it in maybe in a simpler way at this point. I can have a small structure keeping that. I mean, I could have a very simple struct, you know, which is defining. I don't know what is best. If it's best to have a struct with these two values, and then an array of that struct, which can be fine, but is not that easy to extract. Or if it's better, well, it's not easy to extract in the sense that I have one requirement. I mean, the requirements anyway go in a sequence. So requirements number 0 will be the array 0, and the requirement number 1 will be the array 1. So yeah, I think it's probably good enough. I think it's probably good enough. I think it's probably enough. Because if I put it in the requirements, this will be wait a second though, wait a second. But we actually have the buffer here, right? The buffer is chosen for each requirement, and so is initialized. That is very strange though, because the buffer, I mean, everything else doesn't change, but the buffer changes. What I mean is, if I'm mining coal or I'm mining gold, right, and I'm loading this miner dig resource, I'm going to point to the same recipe with the same requirements. The difference is that this buffer, this T buffer resource, will change at runtime, right? Will be coal or gold, and so it will change at runtime. The problem is, if the requirements are actually shared, and so they are not reinitialized, how the hell may it work? Because this one will be reinitialized to gold or coal based on who's moving. That is something that we need to discover, boys, huh? There is something that we need to understand. There is something that we need to understand. Okay, let's understand this 1 second. Let's understand this 1 second. Let's put back this 1 second just that it compiles, right? And I want to run the code. Because basically, you know, what happens is the following. What happens is the following. We have the recipe manager, right? Yeah, the recipe manager. Yes, the recipe manager, which is basically keeping all the recipe loaded in a variable called recipes. Okay, and these ones are loaded flat regardless of the tribe, right? And then we have the tribe 1 and the tribe 2, right? Which actually are loading a recipe tree, right? And the recipe tree is made of nodes, right? So it is a recipe tree which is made of different nodes, which actually are called recipe tree nodes, by the way. And now these nodes have their own characteristics, right? So for example, they have a priority, a wait time, a next step, a cost, and all of that is specific for the tribe, right? But then they also have a recipe. They also have a recipe inside of this. And unfortunately, this one is a pointer. So it means that this recipe is actually pointing to our recipe manager, right? Maybe I can do it in another color, I don't know. So these recipes are actually pointing to the global ones, right? To the global ones. So the point is that if tribe 1 has the same recipe, or even worse, even inside the same, right? Even inside the same tribe, if the tribe 1 has the pointer to the same recipe in different nodes, yes, exactly, like he's the dig resource, right? Now here we start to have an issue, because actually this one will point to the same recipe, and when it's executed by multiple members, I think they may really fuck up. Because unless the T buffer, which is this guy, T buffer resource blah blah blah, is kept at the requirements level, I mean, it's kept at the recipe tree level, recipe node level, it will definitely be overridden all the time. It will be overridden by every execution, and even worse, it will be overridden by each tribe. So one tribe can override one of the other guys. So maybe I didn't understand something, but that is how I see it at the moment, and I want to understand how it's possible. Replace buffers. I think probably this replace buffer is keeping the buffers. This is why. This is why, because the buffer is kept. The buffer is kept within the tribe. We have a tribe buffer, you see, which is actually a property of the tribe. So actually, the trick is that tBuffer buffer name. tBuffer resource, right? Yeah. Is replaced, but when I think it is happening directly at runtime and is anyway on the tribe preparse replace buffers. Preparse replace buffers. And result is returned. Yeah. And the preparse happens. I mean, I hope it happens at runtime, right? Yes, is here in the X. Okay. I understand. Okay, I understand. No, it's working perfectly. It's working perfectly for that part. Okay, I was scared for a second, but basically the trick is that the recipe is saying, hey, I need to mine something, and it doesn't know what is that something. And for him, something is just a resource, okay? So a generic resource, but it doesn't know what is it. And the same is happening here, you know, in the second recipe. Then the tribe object, but is the tribe object, which is obviously specific for the tribe, as a variable, which is called tribe buffers, right? Which is completely specific to this one, and is keeping the mapping between. It's keeping the mapping of the. Is keeping the mapping of the current recipe. Of the current resource he wants to mine, right? And so here actually he will have resource equal to call at a certain run. So let's say when he's running this recipe, and he will have resource equal to gold when he's running this one. So yes, the pointer to the recipe can remain the same, because the pointer to the recipe is not specific to that particular run, okay? Which is pretty smart the way it's built. I mean, it's a bit obscure, you know, but it's not very easy to grasp, but is working, okay? And so this absolutely confirms the fact that recipe is actually shared. So if you have a tribe number 2, right? If you have a tribe number 2, this recipe will be exactly the same recipe of this guy, and so this one will actually point, you know, to this. This one will actually point to that. to the same one. And in this case, these two will point to the same one, right? But it's okay, because then is resolved on the fly within the tribe what he wants to do. Okay, so now that we are adding failures, our problem is that we need to follow the same logic. So we cannot put a value inside of this, because if we put a value which is specific inside of this, it will be shared between all the tribes. So if tribe 1 fails, tribe 2 will also think that he failed, right? So we cannot put it at this level, because this level is shared between the tribes. I don't know if it was the best decision to share it between the tribes, but for sure makes the memory footprint smaller, right? And I think it's fine. So in other words, yes, in other words, what I was saying is correct. So that we cannot keep it inside recipe. I don't know why this guy was naming leaves instead of node. So same recipe shared between nodes and tribes, right? So it's the same guy. It's the same pointer. So what if we make a collection manager? Yeah, we make something similar. I mean, it's not really a separate collection manager, but I think that basically if we keep it inside the node, because we said that the nodes are specific to the tribe, right? The nodes are specific. So we can just keep the information here, or we keep the information here, or we keep the information here. We can keep the information at these 3 levels, no problem. We should not keep it inside of this, okay? Because that's shared. So our only requirement is that we keep the failures or at the node level, or at the tribe level. Well, actually, this one and this one are the same for the code, but or at the node level or at the tribe level. And so I think at the node level is okay, right? I think at the node level is okay. The only problem is that the only problem is that we need a small struct, you know, like I was saying, like I was building. So we need a small struct, you know, that we can call failure log, right? Or failure script or transcript, or we can call it failure log. I think it's okay. And this failure log will actually contain this too, right? And why we need it as a struct? Well, we need it as a struct because we need it as a struct because actually we need an array of that, right? So we need an array of failure logs, right? And this one can be called requirements failures, right? Requirement failures. So, and the idea is that and here we are at the node level, so we are outside of the reuse and everything else, right? So it should be fine. And the idea is that our array, you know, our array is nothing else than a, you know, an array is nothing else than a list, right? It's just a list of values. So the point is that this array will contain this small struct, right? This small struct here of failures and last known values. And inside of this, we will keep one element for each requirement, right? So basically, the array is organized in the same order of the requirements. Order is one-to-one with the requirements of this recipe, right? Present in this recipe, present in recipe requirements, right? I think it's inside these recipe requirements, I think. If I can, no, because I'm in the H file and so he's annoyed and he's saying no, you cannot do it, you cannot do it. Okay, I cannot do it, but it's okay. So is inside our recipe guy. Come on, recipe, come on. Right, and as we said, there is a small struct requirement, and we said that there is, yes, requirements, right? Get requirements. So yes, recipe requirements. Okay. So keeps a log of failures for one requirement. I don't think we need the ID of the requirement here. So we don't have the ID of the requirement inside of this, because basically for us the ID of the requirement is just the order of the array. It's just the element of the array, right? So if it's requirement 0, is array 0. Now, maybe I will have to add it later. So maybe in 15 minutes from now, I will go back and say, oh, we need an ID, right? But we will see. At the moment, I think we don't need it. Okay, so this is all, again, just to recap, this is because we are working on the store, okay? So where to store the stuff. Then we will work on how to detect it and then how to do something else, okay? So we are still, at the moment, we are still on the storing of this data. Okay, so okay, so now that we know that we have this, there is one problem though. The problem is that we may fail a requirement. The problem is that we may fail a requirement, but not fail this one, right? And so basically our array will be empty. This one will be null somehow, and this one will be. So we need to be sure that as we are executing the requirements, we are at least adding a -1, you know, or something in this value. I mean, we are adding like an empty struct, right? Yes. So we need a. We need a failure log. We need a failure log method somehow, right? Which is setting this one. I mean, when we create a new failure log, I think it should be, these two things should be initialized to -1. So I think we will anyway create a failure log. Do I need a void here? No. When we create a failure log, as a default will be created with -1, which is the same thing I was trying to do here, but now I cannot do it anymore here, okay? I cannot because it will be done directly in, okay. So what we can do there is to just initialize this array as an array of failure log with 0 elements. Okay, so that we can do. I mean, it's not really doing anything, but that we can do, so that we are sure that it is initialized, right? So plain shift, an hour of good reasoning behind each line of code. Well, yeah, because you know this thing is very complex, and so I need to wrap my head around it, right? To avoid doing mistakes, right? Because considering the structure is very dynamic and fully scriptable, if we change something wrong, I mean in the wrong place, we will break so many things. So the problem is that we are like inside, you know, a castle, a crystal castle made of so many pieces, but they are all very fragile and all, you know, well, not very fragile, but they are all based on like a central pillar, and then they are all attached to that central pillar, and there are so many of them. And actually at the moment, you know, we are working here, right? We are working here. So changing this may destroy, I mean, may invalidate the whole structure. Now, if we were working like here or here, that would be much easier, you know? We would just, you know, put stuff into it without any problem. But the changes that I'm doing are really cascading, you know, cascading so much everywhere in our code, because yeah, I mean, it's a bit long to explain why, but it is like this. So I need to do it with a lot of caution, right? With a lot of caution. And in fact, you see that I already did it like three different times, and now I came to the one that I think is more correct. Okay, so let's say that we have our array of failure logs, and this one is actually stored on the requirement node, so it's the proper place to store it to not getting override by the other tribes, which is great. And so now the only thing we need to be sure is that whenever we are going through the requirements, right? Whenever we are going through the requirements, if the requirement is properly met, should we initialize our array to the number of requirements at the beginning, or what? Yeah, maybe that would be the best idea. If I just no, I'm thinking if I just put in the clean array, this array, no, the clean array, I just put it in immediately, because unfortunately, because here I'm getting the requirements, right, and I'm running this algorithm, but I need to be sure that I'm not messing up. Or I do a T-map. If I do a T-map, I don't care about the array. And we basically find the element. If the element is not there, we create it. Or we ensure that we always create, because I need to be sure that the array is not fucking up, right? That the array is not, I mean, it's not that I'm trying to write the second the second entry when the first entry is not being added. So that's a bit of the thing. So but anyway, there are only two possibilities, right? There is possibility number one, that the requirement is met. So if the requirement is met, it means that I don't even care about the failures of that one, right? Because it's been met. So do we want to substitute the value? Do we want to substitute the value with an empty one, and so reset basically the requirement because it's been successful? Yes, I think so. 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 So I think that basically we will basically we will failure log. Yeah, this struct actually should not be inside. I think it's a bit stupid to put it inside. Let's put it outside. Let's put it outside the recipe tree because otherwise becomes hard to use. And by the way, I think it should also be a class maybe. But we basically create an empty failure log, and we assign it to our recipe node requirement failure. So the recipe node is this one, so it's best recipe, and we can get requirement failures of I and reset it to an empty failure log, right? You could document success. Yes, we are documenting success like this, I guess, right? So this is documenting success. Now we are overriding the previous failure. So when we do this, we are basically deleting the log. So we don't keep an history of failures. If we succeeded, all the history is gone, at least for that particular item, right? A fast walking man is hard to beat. What does it mean? So okay, good. Now we need to ensure here that so if it's different than -1, yes. We increment this guy, and here we okay. So we are back to the place where we were half an hour ago, I guess, but now we have all the structure correct. So meaning that we have all the data behind that is structured I think the proper way. I hope so. I hope so. The question is the same. At least now we are storing it in the right place. But the point is, how do we store the value? How do we store the current value of this requirement, right? Because this requirement, I think I need to store it when I do the parse requirement, actually. The problem is that do I have the recipe? Do I have the best recipe? No, I have the recipe. Because in reality, inside this code, right? If you go inside this code, the parse requirement, this is where the code is actually. Well, I could return it. I could return maybe by reference here. I could return by reference the value in case of success. Or we change this. But no. This one we cannot change, right? Because this one is true, even if, or can be false. But we need a number. We need a number we progress. So we need the last known number, right? So basically, it's this count. This count is this count. Yeah, we need a current count. We need here, I think it can be an int, current count. So this function should give us, as a result, right, the thingy. Boys. Oh fuck, we need to change documentation. You see how nice we were? That we were documenting every single parameter? Fuck. We were too good, huh? That's the problem. We were too young, we had too much time, and we could do this. Current count is a return, so returns the current progress. Well, the current value of this requirement. I don't know if it's very clear, but probably not. But this is what we are returning. So in theory, this count here is, I think, can be directly set to this. I think we directly say current count. I think we can directly say current count. Now the current count must be overridden, okay? So we don't, I mean, we cannot take this value, right, and use it, right? So it is a return value, right? If quantity is less than 0, return false. So for example, in this case, you know, current count is this. No, wait, I'm doing something stupid. There is check members, which is just returning, because this one is returning a boolean, fuck. Is returning a yes, no. But if false, if it's false, it's not telling you how many, right? And we needed the how many. So we need to change this function as well. Yeah, we need to change this function as well. Because this one is just returning a boolean, but it's not enough for me. I need the current count here as well. I need that. Fuck. I need that. Now the only problem is here, because here I don't know exactly. Handle the special case where name is number. So if type equal to number, total check if the total number is correct. We don't care if it's idle or not. Number less than 0 or number less than members return true. Bro, but I need a I need my current members, bro. I need it. I need it. Otherwise, I need it. Yeah, I'm adding a lot of lines, a lot of new lines and a lot of changes in the code, so we will have to retest a lot of stuff, boys. But I'm trying to do it as carefully as I can to avoid breaking things, right? So that, again, this part of the code is risky, is very risky, so I need to be careful not to break it, because I don't want to spend, you know, 3 days retesting everything where things are not working anymore. I mean, if you are persistent but not overextending and rushing. Okay. So I understand. Yeah, I think I got it kind of right when you said that, but I was not sure. Like walking versus running, right? I mean, walking being slower than running, but being more persistent than running. Yeah. I agree. Okay, so I think we are good. We are returning this number anyway. So this function will hopefully this function exactly. Okay. Will be a bit funny to debug, eh? I mean, but anyway. I mean, debugging this is fun. It's kind of fun. And I'm slightly sarcastic, but yeah. I mean, depends how you take it, but debugging this will be interesting. So here we return this. What is this? I have no idea. Okay, and here is doing the thing, right? And it's okay. And it's okay. But we got our number meanwhile. We got our current count. Now, if he's a oh fuck, it's the same problem. Yeah, we need to do the same for check resource. Same thing. We need to do the same. Okay. Okay. I think it would be the same for all of them, but anyway. Let's go one by one and see where we have the problem. Requirement type item. Yeah, it's the same. So it's checking if we have enough. But this time at least we have the count, right? So I think in this case I can go with current count directly, so it's a bit easier. I don't have to modify the underlying function, which is good. Now I think this is a kind of a 1-0, so the knowledge, or you have it or you don't have it, right? So it's a kind of a 1-0 thing. It's a kind of a 1-0, so it's a binary operation. So what do we... My character is going a bit crazy. 1 second. Trying to recalibrate. Sometimes I need to recalibrate them because it's going a bit crazy. Okay, so let's not lose track. I'm saying yes, this one is kind of a 1-0, right? Because this one is how many items you have of this type, and okay, we have a count. This one is, do you have this knowledge? So do you have this knowledge is a 0-1, right? And how do we track this? So there is really no progress in this. So this one cannot have progress. This one cannot have progress. So I think we will just count it, you know, as 1 or 0. I mean, I don't have any other way, so. Do we know? The question is, do we know? And do we know? And do we know? So what do? We do. Do we know? Do we know current count equal to 1? Otherwise, current count. Oops. Otherwise, no, sorry. What the fuck? I'm typing. I'm crazy or not? Yeah, I'm kind of crazy. Okay, current count is equal to, do we know 1 or 0? Okay. Fine. Fine. This one is the same, because you can have this or you cannot have this, right? Requirement recipe. This is if you have that recipe or not. Get recipe name. Now this can be empty or no, this one is returning always true. So this one is, so in this case our current count is always 1. There is no possibility to fail, right? And by the way, when it's returning true, we will not even read it. So in theory, we could leave it empty, but just for completion, you know, just for sake of consistency, I'm putting a 1. But this line will never be used, right, in the calling function. But it's okay. Memory is a bit different because he has this freaking randomization parameter. He has this kind of randomization. Random between 0 and 1. Probability, random quantity divided by 100. Yes, this was the thing. So if probable and my tribe and not my tribe find memory. So let me do this. Bool. Do we remember? Do we remember or not? And so I think I can do the same as do we know? I can do the same, boys. Do we remember, yes or no? Okay. Ah, we are at the end. Okay, good. So here are all the cases. So this means that now, for all these cases, we have a value that we can use and is set all the time, right? Is properly set all the time. That is providing us an indicator of progression. Not of success, but of progression, right? So when we fail, we know if we progressed somehow, right? So all of this is done because all of this is done. What the freaking hell? All of this is done. I did that because right? I did this because now when we parse the requirement, we know the current value that we achieved. So if you wanted to get 100 gold and maybe we achieved 89, this value will be 89. And so I will know that I'm at 89, right? And so I can evaluate if not here, because here we're just resetting the failure because we did a good job, and so it's not a failure, it's a success. But here that we have the failure, right? Here that we have the failure. Here that we have the failure. So the first thing, well, the first point is that I can finally set my last known value, okay? But the second point is that if it's not the first time and you see now how all the pieces of the puzzle are coming together in this line. All the pieces of the puzzle are coming together in this line, okay? I need a shorter one. Look at this. Wow, it took like nothing to do the border as usual and then hours to do the white parts. Okay, all the pieces of the puzzle are coming together in this particular point, okay? Because, well, there is also another point that will be very good, but this one also is good. So, so the question is, if we progressed since the last time, okay? And in our case is, if our current count, whatever it is greater than this, no, is greater than last, yes. So if it's greater than that, we do not fail. So if it's less or equal, we fail, right? If it's less or equal, we fail. If it's less or equal, than the last time. Yeah, so, I mean, less is very hard. It's probably impossible. I mean, like, that I lost gold during the... there is a big problem though. Fuck. There is a big problem, boys. There is a big problem. I mean, we can ignore it, okay? We can ignore it, but actually it is a problem in the logic. It is a problem in the logic. Basically, the problem is the following. Fuck. No, but it's not a huge problem, but is anyway a problem. Please, Paint, be nice with me. I'm using you instead of Photoshop, so please be nice with me. Okay. We have the following problem. Tribe 1, collect gold. Spend gold for building weapon. I mean, a weapon of gold is very stupid, but anyway, for building throne, no, for building amulet, okay, for building amulet. So there is kind of an issue though, there is kind of an issue. Okay, so remember that we execute this continuously, right? And we are evaluating failures based on the fact if the numbers are going up. So if I collect gold and I get 10 gold, and then at the next run I see 11 gold, I say, wow, I progressed. And then I see 12 gold, I can say, wow, I progressed, right? The problem is if there is another behavior which is executed by another member of the tribe, which is actually to spend gold, right? Which is actually to spend gold. So this guy will do minus 10 gold every time he's building an amulet, right? When we are checking this requirement, what we will see maybe that we have 10, 11, and 12, and then we will have 2. because 10 has been spent by this guy, right? And then we will have 3, and then okay. But the good news of that is that we will consider it a failure only at this point, unless the amulet is costing 1 gold, and then it's obviously a problem. But if the amulet is costing 10 gold, right, we will consider a failure only there, because we see that we go back. We say, oh fuck, we went back, so there is something not working. But then here we will, but then this one we will consider is a success anyway, and this one also a success, or anyway a progress, right? So the problem is if the problem happens only if the amulet or the let's say the consumption is exactly at the same rate of the collection, and so every time this goes, you know, 10 11 10 11 10 11 10 11 continuously, and so we continue to say failure 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 failure, right? Because we see that this number is not going up. In reality is getting properly used by another member of the tribe to build something, and so in this case, at a certain point, this guy, the first member of the tribe, will say, fuck it, I'm collecting gold since 2 hours, but someone is using my fucking gold, I'm stopping collecting gold. So actually with our new algorithm, this guy will stop. This guy will stop to collect gold, because this one is using too much. Because this guy is upset that he cannot reach the goal he wants to reach. Assuming that this one has a target, for example, of 100, right? Because if he has a target of 1, then obviously he will not complain, because every time he gets 1, his task will be completed. But if for any reason he has a collect gold by 100, right, he will fail. But I think this is a very special case. I don't think it will actually happen, because I think that if we have a material to collect, we will probably put this value in the script to be the same as the cost of the amulet, and so I think it will not actually happen. Can we set the new current when we spend? No, because the spending is a completely different branch and a completely different algorithm, right? So we are counting failures inside a single task or a single requirement. We are not sharing failures between. So we, at the moment we are not considering what the other guys are doing for the failures. I'm only looking at my job, if I'm failing at my job or not, right? So the guy is mining, and he's putting gold in a bag, right? So you have the guy, you know, which is mining, which is rock pick. I want it to be another color. Okay, which is rock pick. And then he has a bag of gold here next to him, right? And he's filling it, with his work, right? Because here he's taking a rock of gold, right? And sometimes every 100, only every 100, is looking at the bag to see if he did a good job, right? But the problem is that there is another guy, which is actually here, which is stealing from this bag to make the golden amulets, right? To make the golden amulets. And at the moment, this first guy, the guy number 1, doesn't really know that number 2 is stealing from his bag, right? He doesn't know. He's just looking at his task. The only thing that he knows is that he needs to mine and needs to get 100 gold. So if this guy at the same time is stealing resources, our algorithm at the moment is not considering that. And so he will think that he's not reaching the goal. You know, you say, fuck, I'm not able to reach the goal. So at a certain point he will stop. We say, fuck mining, I will never get to 100, right? I will never get to 100. And this guy will finish the gold. And so also this guy will say, fuck the amulet, I will never build the amulet because I don't have the gold. So this guy will stop and this guy will stop. Now, at a certain point, I think we will anyway reset, you know, the failure. So at a certain point, which is the third part of our task, which is do something else, and then, yes, there is also another one, which is reset the failure after some time, right? So that we try again. Let's say reset the failure is not a good way to say. Try again, okay? Try again after some time. Too much, the guy says the F word. He's saying, fuck this guy too much. So anyway, at a certain point, we will reset the wheel of this guy. So the wheel of this guy will restart. And the wheel of this guy will restart. So they will start again to mine and to steal the gold and to build the amulets until we reach the threshold again, and they will stop again. But I think it is a very special case, right? It's a very special case that I think will not happen. But is a possible case, right? So we need to know that it exists. And this one is created by this less than, right? It's created by this less than, because if I remove this less than, then it means that we consider failure only if we are not progressing, but not if we are losing point. Okay, we can also do this. We can just compare, you know, we can just say, are we at the same value or not? If we are at the same value, it means that we didn't. Yeah, but it can still happen though. It can still happen because if this guy is stealing exactly 1 and this guy is mining exactly 1 at the same time with the same timing, so I think the case may happen anyway, but we don't care. Is fine. And what happened in the process when all the tribe needs to fight? We have tribe stereotypes, let's say. So the tribe is made of warriors, is made of builders, is made of gatherers, right? So in theory, at least the way we script it usually is that only the warriors are fighting, because they are the only ones that have the ability to fight. Now there can be a tribe that is made of only fighters, but yeah, which is a possibility, right? So if there is a tribe made of only fighters and they can also build, so it's a bit of a mix, we can give a priority of building versus fighting. So if you are getting attacked, we can say that getting attacked is triggering a behavior of defense which is higher priority than building, right? Which is higher priority than building, which brings you know, the AI. I don't know if you know StarCraft, but the pylons of StarCraft, right? The pylons of StarCraft, you know, if you don't have the pylons, your buildings are not powered up, and so you cannot fight. So there is a case where the build, I mean, where you will have to decide to keep your buildings alive or to fight, right? And I don't know, this one we don't have an algorithm yet, but Someone can put it in our scripts. So let's say there is one guy fighting and the other guy healing, right? And the other guy healing. So how much he should spend fighting and how much he should spend healing other members that are wounded, right? So it is a bit of the algorithm that we can create, but I think that one can be created in the scripts and not in the C++ code. I think that our scripting in the database can do that. Can do it based on thresholds, can do it based on number of people dying, can do it in different ways. Okay. Only if we did it, if we didn't progress since the last time, we consider it the failure. Okay, so this is what this if is doing. And then we are incrementing the failure counts, right? Okay. So I think that this is doing what we want for the first part, which is store the failure, right? Store the failure. I think we can test it before going to the other ones. So I think we can so now we know that I think that the tribe should tell us about the failure, right? The tribe should tell us because otherwise we need to debug it. Is very annoying. I think we can just I think we can just maybe do the second point as well. We can do the second point as well. So that we have a way to print out the fact that we reached a critical failure, critical failure point. So that check needs to be done in our mythical, famous, now infamous get next recipe. So which is where the whole problem started, right? Because the problem started when here we are selecting the wrong recipe and we are selecting the recipe that is failing continuously, right? While we want to move on to the next one. So I think that what we can do here is so that's the first check. This check is they have the same wait time, but this node has higher priority. Now, where do I put into this the failure thingy? Where do I put the failure thingy? Because there may also be the case, you know, where all my nodes are failing and so I don't have a way out. Yeah, I also need to consider this case, that the failures are, or maybe the node has only one requirement and that requirement continues to fail. Right? If that requirement continues to fail, then I think I will have to report to the father that node cannot really continue, but this is probably a bigger problem to tackle now, so I will not tackle it now, but Okay, I mean, let's set aside 1 second the fact that I may come up with 0 nodes, because it may happen. It may happen that all my nodes are failing and so I cannot do anything. But that's a bit of a special case as well. But we need, I think in that case, you should continue to try to do the one that is failing, right? So do we want to select the one with less failures? Do we want to select the one with less failures? Does it not have less waiting time? And then is promoted, you know, is promoted to best node. And then is promoted to best node. Is promoted to best node, but actually, you know what we need to have? I think we need to have a failed node. I think we need to have a failed node and keep track of the failed node. If we don't have any better ones, we will still execute this, right? So may not be the best of the failures, okay? So the best of the failures is something that at the moment I would not do. But the best of the failures, like if searching for gold failed 10 times and searching for silver failed only 5 times, at the moment I'm not doing a differentiation saying that it's better to search silver, right? I'm not doing that. But what I can say that if my node requirements failures, okay. I think we need to check. I think I need to scan. Yeah. I think I need to scan. So or we expose the fact that it failed in a global variable every time. In a global, I mean global to the node. I mean in a variable to the node that one of the requirement failed. Otherwise, we will have here to scan them all. We have to scan them all to know. So we need something like. Did it fail? We need a function, you know, that tells me if this node failed above a certain threshold. I think I need something like this. Is critical failure. So I'm asking to the node itself if he has a critical failure or not. And this function should be here somewhere. Should be a boolean. And and this function is the one that we will have to decide together when too much is too much, you know, when too many failures are enough to stop the particular node from getting executed. So is critical failure basically is the number of failures to fulfill the requirements too high, and so we want to stop the execution of this node, right? Right? So this is the meaning of that function, right? That is the meaning of that function. So for now we can do something very simple. We can scan all our requirements, because we need to do it, right? There is no other way. So we need to scan our failure thingy. We need to scan this, and we need to check I think I can probably do it a bit better, though. I think we can probably... I think we can probably do it as we execute it, because doing this scan every time on every node is super stupid. I should not do it. I should not do it. Is slow. I mean, it's a bad idea. So I think we need to keep, the best will be to keep on this guy, you know, and max failures, where max failures is the highest number of failures we got on all requirements. We got, I mean, among the right? So analyzing each single requirement and the number of failures he had, what is the max number of failures on this? What is the max number of failures on this guy, on this node, right? What is the max? So it's basically the critical threshold, right? The critical threshold. So I think this one we can just populate it. I think it's fairly easy. We can just populate it when we do our thing inside the recipe. We have to be careful on the reset, though, because when we reset, we also need to reset the maximum. Because if I never reset the well, I can. I think as soon as one is succeeding, I think we can reset the maximum, and this means that worst case, it will execute it once. Okay, that is the worst case that may happen, because it will run once, see there are 0 failures, trying to execute it, and then the first time you execute the next node, it will find 10 failures, right? So I think this could be okay. I mean, it's not really the best, but okay. So here we reset the failure on this requirement. Here we reset the max failures as well. I mean, here I would say I would put you fix me because I think that I'm not completely comfortable with this line, okay? But I think it's okay. I mean, it may work, but it may generate some cases that are a bit weird. So, okay, so in this case, what we do? We store the value at the present time, blah, 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 blah. So when we increment the failure, yeah, when we increment the failure, we need to be sure that we are... So if this number is greater than max failures, right? If this number is greater than max failures, then we set max failure to this number. Okay. Okay. So that, yeah. Including the plus plus or no? Yeah, before, after the plus plus, right? After the plus plus. So we increment, then we check set max failures to the new maximum. Okay. So this is adding 1 to the failure count, and it is basically setting max failure to the new maximum. Okay. Nice, nice. So if I do this here, the good news is that we can avoid doing it here. And so it means that in this case, we have the max failures. So we can check, for now we can do something very simple. If max failures is greater than 3, okay, or is greater than 2 even. If max failure is greater than 2, then we return true, okay? So obviously this one is temporary, okay? Temporary, add a real algorithm to decide when it's critical, okay? But because to decide when it's critical is this step, detect the threshold, right? Or define the algorithm for the threshold. For now we just say if it's greater than 2, we consider it critical. Okay. So now going back to our selection. So going back to our exactly. So if the node has a critical failure, we do two things. So meaning that it's stuck, right? Meaning that it's stuck. So if it's stuck, we do two things. We set the failed node equal to this node, so we know that so we keep track of the failed node. Basically, this is this comment here, and this comment here will go down because and then we skip it. So we skip. So this will be a continue or something. This will be a... Well, I can just do this. I can just do an else if. And this means they will be skipped, right? Right? But what I want to say is that when we arrive at the end of the algorithm and the best node is equal to this node, then we return the fail node. Right? And if it's null, is null. So we start as null. So if it's never assigned, okay. So if we don't have any better node than this one, then we will return the failed node. So basically, better this than nothing, right? So this means that if I'm failing at mining gold, but I don't have any other task to execute, right? At this point, it's better if I continue to mine gold, because there is nothing else I can do, right? There is nothing better in my brain. It's funny anyway. Okay, let's compile and see what monster we created. Let's compile and run it and see what monster we created. Now, it will be interesting to print out when a node is considered a critical failure, right? So I think that here will be very interesting to know. So here we want to print out, right? Here we want to print out that here we want to print out I'm lazily copy pasting. Found critical failure for node fuck, we will not know which one, at least here at this level, but okay, I think it's better than nothing anyway. That this guy has a name? No. What it that this guy has a recipe, and recipe has a name, maybe? Yes, recipe has a name. So, but the point is that we will identify the recipe that failed. We will not identify the requirement that failed, right? Which is maybe something we can do next, just to improve our code. But if the best node goes for gold and the player are killing them, I thought you wanted the tribe member to do something else. Yes. Yes. He's doing something else. I mean, when we detect a critical failure, we are excluding the node from the list of the stuff he needs to do. So if he has 5 things to do and one node is failing, he will now select the other ones, right? Because he will exclude that one. So he will execute the others. The case is if he doesn't have anything else to do because his brain because his brain contains only mining gold, then he cannot do anything else, right? So at the moment, if he has an option, he will do the other option. If he doesn't have an option, he will just continue, which is okay. He cannot do anything else. I mean, he can go to sleep. He could ask for more work. Please give me something else. I cannot finish this gold task. Please. Okay, so what we want to debug. I don't know. We can also let it run, but we know that mining gold is failing. We know it because we experienced it the last time, right? So we were blocked. We were blocked on that. So in theory, we should go through this after a bit, after some time that our guy is trying to mine gold. So now the debugging part comes in, which is the one that I said it would be fun. Okay, we don't care about that. The only thing that we care is if we are detecting properly that he is failing, right? That is the only thing that I'm caring about at the moment. And considering it's midnight, I hope he can do it. I hope he can do it. But anyway, even if he doesn't do it, you know, all the structure is in place. And so it's just a matter of, you know, properly debugging the thing. At the moment, it's just loading the main level. So it's just spending time because I rebooted my machine. And so, okay. Okay, loaded the map. And so now the game started. And so now the NPC are starting to move. So here the tribe found one available member, one idle member, right? And he's trying to assign a job. Considering we modified this function, let me just check if my failed node is not messing up anything, right? I just want to be sure that this function is still returning a proper... Yes, okay, it's doing it. It's doing it, it's doing it, it's doing it. So it's still returning a proper... yeah, okay. Okay, so we didn't break that part at least. Let me see if we did any damage to this one. If it's still running as expected. We need to check if the current count is correct, huh? We need to check that. Let me see, current count. Current count was set as 1. Because we are checking which requirement. We are checking the first requirement, which is what? The fact that we have one member of the tribe. Yeah, perfect, perfect. That's good. We are checking if we have enough tribe members. It's actually asking for 16, but we actually have only 1, and we properly reported 1. Okay, so so it is correct. For now, is correct. So the last known value will be -1, yes, and so we will skip. Fuck. Okay. Because we didn't... Wait, no, there is a problem in this code. There is a problem. There is a problem. We need to initialize the array. Or we initialize the array with empty failure logs, which is a possibility. Or every time we go through this code, we check if that particular requirement already exists, and if it doesn't exist, we because we will get the same error here. Eh? Can we have a dynamic array? I think it's a T map. Huh? I mean, I wanted to use the T map from the first place, but because you know the problem now is that our array doesn't have a fixed value. Yeah, we need to use a T map, boys. We need to use a T map. We need to use a T map. Otherwise, it will just be a mess. This order 1-1 is shit. Is shit. This idea of order 1-1 is a bad idea. So key is the requirement. Step, right? Yeah, because with the array we are just going to be in trouble more and more. So we're just going to be in trouble. Let's change it to a T map. I know it's a bit annoying, but it's not in too many places anyway. It's not in too many places. I think is reasonable change, and we'll make this better overall. Basically here, what we need to do. Considering is a unique T map, right? We need to add I failure log, and so if it already exists, it will be replaced. So this one now is fine. The problem we will probably have it here, because I need to do a find. I will need to do a find ref whatever of I, and see if I mean, first of all, if it's valid, and second, if wait, maybe I can put it outside. So if flog is found and flog last known value, no, wait. If flog is found, yes, and flog last known value is different than -1, because this is not a pointer. Fuck, this is not a pointer. It is not a pointer. Or the default value. Okay. It's finding the default value in case it's not present. So I can just do this. I can just do this and it's okay. Okay, fine. Then here we have a bit of a problem because this becomes this. Well, it's even shorter, so I guess it's better. Okay. Then we did the change. I think we did the change. No, we didn't. No operator takes equal. Yes, because this one now is not needed anymore. The T map doesn't need to be initialized. I mean, it's well, yeah, we can still initialize. Wait, we can still initialize it. Why not? We can still initialize it with a T map of int and failure log. Why not? We can still do that. It's just an empty map, which is fine. Okay, nice. We can run it again. I mean, it was a bit of a change, but it was not too painful. So I'm happy I did it, because now the check is less prone to failure. Right? This one and this, yeah, these two mainly. These two, because now here is adding and overriding if it exists, and there is just checking it. So it should be good. Should be good, boys. Boys, should be good. Get best recipe as level. Okay, this one we already checked. It is not fucking up. What? Ah, fuck. We didn't initialize max failure, so is a crazy number. We didn't initialize it. Okay. Makes sense. No issues. No issues. Yeah, it was like 28,800 and something, just because it was a random value, right, boys? Fuck, sorry. I was typing in the other. Okay, so now because it's just an artist that contacted me because they want to work on plane shift and such, so I'm just answering. Artists are always hard to catch, you know, so as soon as I see them interested, I'm like jumping on them. Jumping on the artist. By the way, if you know any artist that wants to help, let me know, boys. If you know of any artist that might be interested. Okay, let me see if this one is not dying. Okay. Is not. Very nice. Let me see if this one is not dying. Okay. Perfect. It did what we want him to do. Perfect. Perfect. I don't know exactly which requirement we are parsing now, but we are parsing the call quantity. So this one will fail, obviously. Yes, and it will add the recipe. Fine. Fine. But it's the first failure for this guy. So I will skip it. Okay, perfect. Perfect. Up to here seems to be working okay. 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 I will let it go. I will let it go. I will let it go. So now the tribe sent one guy to mine. Okay. We are waiting the guy to actually mine and come back. Now, we need him to mine gold, because if he's mining coal, he's actually succeeding in the task. Yeah, at the moment he's mining coal. So mining coal is actually successful. So we should never reach the critical rate, the critical failure rate, right? And so it should, so that should be fine. Now, even if there are two levels of failure, one failure is I cannot complete this task, and the other one is I went to mine but I didn't find there anything, right? They are two different levels. But we are checking the parent one. Okay, now in mine for call. So now we want, hopefully, that he starts to mine for gold, right? I hope he's gonna do it. Okay, he went to mine again. So he's walking to the location, even if we don't see him, but I know he's walking to the mining location. Yes, and this time he's searching for gold. Okay, this time he's searching for gold. So the second time is going. The first time we don't consider a critical failure, right? But the second time is failing, we will start to add failures numbers, right? We will start to say, we didn't do it. We didn't do it. Yes, up to now is working fine. But we need to see if now we are accumulating failures, right? Or not, because the point is that we want to accumulate them. At the moment, nothing is happening. I don't know exactly why. Okay. We have the mine dig again. Okay, but this time I think, okay, let's check this time, because this time is the second time that we do this thing. So in theory, my no, this one is fine. Is the next cycle? Is the next cycle? Because this one is fine. But the next cycle, it will fail exactly. It will fail. Okay, here we are exactly where we wanted to be. The only problem is that, okay, let me do this. Why is -1? Wait a second. Did we ever add? So if we always fail, right? Fuck, we are missing the code to tell him that the next one needs to count, right? Because actually here he is not finding it again, right? Yeah. Okay. 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 So we need to do what? We need the next one will count. Yes, the next one will count. So best recipe. So we need to do something like this. So we need to do. So the first one is not counting, and I'm fine with that. Well, in theory, we could even just count the first one as well, but. Should we count the first one as well? Should we count the first one as well? Because maybe if we count the first one, is a bit, the code looks a bit simpler, right? And we just can raise our threshold. You know, we can raise our threshold from 1 to 2 and it's done, right? Yeah, I think probably ignoring the first failure was kind of a nice idea to, because logically the first time is really by design, but it makes the code a bit duplicated and I think is less readable, because basically what I have to do here, I will have to do best recipe requirement failure add with exactly this line again. No, with let's count all the failures. It's simpler. Let's count all the failures. We just remove one from the threshold. Okay, we will just do that, which is simpler. So we need to. So check if we already failed, right? If we didn't fail, I mean, if we didn't fail yet, we are going to fail now. Right, we're going to fail now. And if we I think it's exactly the same. Yeah, the beauty of this is that if I don't ignore the first one, basically I don't need that if, I don't need that check. Because I'm just getting the previous value. If it exists, good. If it doesn't exist, it's -1. And in both cases, if it exists, I'm doing a ++ and I'm setting it. If it doesn't exist, I need to start from 0 though, otherwise it will not work. I need to start from 0, boys, or it will not work. Because -1 will go to 0 and then 0 to 1, and so yes, we will ignore 2 then. So I need this thing. I need this thing to start from 0. Okay. Okay, I think now is good. Well, I don't know, but I think it's better than before. But basically, yeah, it seems that is correct. Is correct, but I'm refining. You know, I'm refining the way it works a bit. But now I think it should be okay. So just to summarize for you, right? Because now I also need to go. What we added is a storage, you know, which keeps track of which requirements are failing and how much they are failing for each recipe that is executed in the tree, in the recipe tree, right? So in all the actions that the tribes needs to do, and then we use this storage of failure as a kind of a warning of a critical failure when we are reaching a certain threshold, right? That at the moment is set as 3, just as an example, but we can then put an algorithm behind that, right? And when the threshold is surpassed, right? Already now in the code, we are skipping that particular task and we are giving other tasks priority. Okay? So this is basically what we did tonight. Okay? That is what we did tonight. So that thing is now in the code. Now, if it's working perfectly, I don't know. But let me say that it is in the code and should work, right? Now we need to test it a bit. So at the moment it's running, but unfortunately I really need to go. I really need to go. But anyways, you know, now we need to test it a bit, see if it's properly accumulating the failures, and then after that we will move to the next step, which is defining the algorithm defining the algorithm of the threshold, because now we are detecting the threshold, but we need to define maybe a better algorithm for it. So define algo for threshold, and then, well, do something else is already done in theory, right? So at the moment we did this one, this one, this one, and we are missing a better algorithm for defining the threshold, and we are missing the try again after some time. But the do something else is already there, because he will try to do something else if he's not able to do that task, right? Based on the failure thing. Okay, guys, I'm gonna go. So thank you for watching. If you're new to the stream, please click on follow on Twitch and subscribe on YouTube. And also, if you want to check our Patreon site, is patreon.com/planeshift. We are actually 53. Our goal was 50. So I think maybe tomorrow I will raise the goal. I still want to, you know, be few days with...
Good night. Bye-bye.
Good night. With, you know, with a goal that has been surpassed, which is always very nice. Let me see if someone is online. No one is online. Okay, well, if no one is online, I think we're just gonna go. I think we're just gonna go, boys. It's time for sleep. See you. Bye-bye. Bye-bye. Good night.